I'm now going to look at two more examples of hypothesis testing, this time using the Poisson distribution. Let's start with this one. Over many weeks, Jack is late for school on average 8 days every 10-day cycle. After being promised a reward if his punctuality improved, Jack was late only 3 times during the following 10-day cycle. Find the critical region which would show an improvement in Jack's punctuality. Is there any evidence at the 5% level of an improvement? Okay, let's start off. We have to put down our null hypothesis first, H0. That is the no change hypothesis. We're now dealing with a rate. It's no longer a probability. We're looking at a Poisson distribution. So we're thinking here that the mean rate, the mean number of days he is late, is still 8, no change. So that is the null hypothesis. And the alternative hypothesis, which we have to write H1, we're looking for whether there's an improvement. An improvement will come if lambda is less than 8. And this is the alternative hypothesis. We are only interested in the lower levels, so we have a one-tail test. Okay, we've got x is the number of days late, is going to be a Poisson distribution with mean 8. That is working from our null hypothesis. If x is the number of days that Jack is late to school. Then we want to look down at the lower end, the probability that x is less than or equal to 3. If we use cumulative Poisson tables, is equal to 0.0424. That is less than 5%. We want to go the other side of 5%. We need to go up 1. X less than or equal to 4 is equal to 0.0996. That's bigger than 5%. We're dealing with a one-tail test, so we take the value which is less than 5%. So 3 is less than 5%, 4 goes greater, 3 is the critical value. CV is x equals 3, and therefore your critical region is x less than or equal to 3. Well, Jack was late 3 times in the following 10-day cycle. So Jack was late 3 times. That tells me that my statistic, my test statistic, is x equals 3. That lies in the critical region because the critical region is less than or equal to 3, lies in the area where we're going to be surprised. Therefore, we reject H0, and we conclude that there is evidence that Jack's punctuality has improved. Copy out the question. A full conclusion is always needed. Notice that the actual significance level is 4.24%, and this is the probability of rejecting H0 when it is in fact true. Very similar to doing the binomial. The difference, of course, obviously, is in how you do the calculations, what tables you look in, and so on. Okay, a second example. Accidents used to occur at a road junction at a rate of 7.5 per month. We have a new housing development built near that road junction, and the traffic police wanted to know if there was any evidence of a change in the rate. That's the thing that you should notice first, a change in the rate. We're going to be looking to see if there are significantly more accidents or significantly fewer. We're going to be looking at a two-tail test. It is that point where we decide whether it's one tail or two tail. A change in the rate at which accidents were occurring at that road junction. Use a 5% significance level to find the critical region for a suitable hypothesis test using the value closest to 2.5% in each tail. You should be beginning to realize exactly what we're going to write down first. H0. H0 is no change. We have 7.5, it's Poisson, it's a rate of that, it's not binomial, it's lambda equals 7.5, and there is my null hypothesis. My alternative hypothesis, H1, we want to see if there's a change. So we're not looking for lambda bigger than 0.75 or less, we're looking for both. In other words, we're looking for lambda no longer 7.5, and this is the alternative hypothesis. We are looking for a two-tail test, and we want the closest to 2.5% in each tail. Well, if X is the number of accidents per month, then X from the hypothesis, this is X twiddle P0. The hypothesis says we're working with a mean of lambda 7.5. So that is where that figure of 7.5 comes from. Now we need to find the critical values at the bottom end and at the top end. So let's look at the lower end first. Probability that X is less than or equal to 2 is 0.0203. Probability from your cumulative tables less than or equal to 3, looking it up, is 0.0591. One is below 2.5%, the other's above. One of these two must be the closest. That one, the top one, is the closest to 2.5%. So my critical value is X equals 2. That's the lower critical value. Let's look at the other end. we start looking in the tables, we find that a good place to start is x greater than or equal to 13. Doesn't matter if you don't get this best value straight away. You can always get there. 1 minus p x less than or equal to 12 is 1 minus 0.9573, which is 0.0427. That is greater than 2.5%. We need to move down to get less than 2.5%, so we need to move out. That's probability x is greater than or equal to 14. That is 1 minus p x less than or equal to 13, which is 1 minus 0.9784, and that is 0.0216. We now have one more than 2.5%, the other less than 2.5%. This is clearly the closest. So the 216 is closest to 2.5%. And so my upper critical value is x equals 14. Critical region is what we were asked for. And so the critical region is x less than or equal to 2 or x greater than or equal to 14. Remember, we always go less than or equal to or greater than or equal to. Just notice that the actual significance level the probability of rejecting H naught is 0.0203 plus 0.0216, which is 4.19%.